Welcome back to DeFi Exploits Explained. Today, flash loan reward manipulation in 3 clear acts. First, the honest flow, how a normal staker earns a fair reward. Then the attack, where someone with no money of their own walks off with almost everything. And then the fix, and every act we prove 3 ways. On a diagram, in a test where you watch every balance change, and then live on a public blockchain where I run a command in the terminal and we check the result on Etherscan together. Let's go! The first the setup, let's be clear about the money because it matters. A staking pool lets you deposit a token and in return you earn a second token, the reward. And that reward is not some worthless AU, it's a real tradable token. Think of something like sushi or cake with a live price on exchanges. The pool holds a pot of them. The protocol's rewards budget, say 100,000 tokens worth about $100,000, meant to be paid out to stakers over time. You earn a share of that pot in proportion to how much you stake. So when an attacker drains the pot, they're stealing $100,000 of real sellable tokens and they cash them out on the market. The bug that lets them is subtle. This pool measures your share at the wrong moment. Let's see honest first. We build it in Foundry. Here's the skeleton of the staking pool. It tracks how much each person staked and the total, and it holds the reward reserve, the pot. Stake puts tokens in, on stake takes them back, and claim pays out rewards. The one that matters is claim, so let's fill it in. But here's the claim function. Your reward equals the pot times your stake divided by the total staked, which is exactly your share of the pool. It looks perfectly fair. But notice when it's measured, right now, the instant you call claim, it asks how big are you this second and never how long you've been here. First, let's use this pool honestly, and it behaves perfectly. Act 1, the honest flow on the diagram. 2 ordinary stakers. Alice stakes 1,000, Bob stakes 1,000, so the total is 2,000 and Alice owns exactly half of the pool. Now the reward. The pot is 100,000 reward tokens, worth about $100,000. Since Alice owns half the pool, she earns half the pot, 50,000 tokens, which she can sell on the market for about $50,000. Bob owns the other half and earns the other 50,000. The formula on screen says it plainly, your reward is the pot times your stake over the total. Alice staked half, so Alice earns half. That's honest. You're paid proportionally for what you really put in. Hold on to that number. Alice earned half. Now let's prove it. Here is the honest test, and it reads like a story. We fund the pot with 100,000 reward tokens. Alice stakes 1,000, Bob stakes 1,000, so the total is 2,000, and Alice is half the pool. Then Alice claims, and we print exactly what she walks away with. Watch the numbers. Run it and follow the balances. The pot to share is 100,000. Alice stakes 1,000, Bob stakes 1,000, total 2,000. So Alice owns half the pool. Before she claims her reward balance is 0, she claims and after, she's holding 50,000, exactly half the pot, her fair share for staking half, and 50,000 is still in the pot for Bob. That's the honest flow proven. Now let's watch it on a real blockchain. We deployed this same pool to Sepolia, a public Ethereum testnet, through my Chainstack node. So let's read it live. In the terminal, I asked the pool a simple question with cast, what's in the reward reserve? It answers 100,000 reward tokens. That's the real sellable pot worth about $100,000 sitting on a public chain. Now the honest stakers go in, and here's where I want you to look. Not at the status or the ID, but at the tokens that actually move. This is Alice's stake, live on Sepolia's Etherscan, and Etherscan lists every token transfer that happened inside it. There's exactly one. 1,000 LP tokens leave Alice and land in the staking pool. That's what a stake really is on chain. Her tokens moving into the pool. One honest deposit, 1,000 in. Bob does the same, and again one transfer tells the whole story. 1,000 LP tokens move from Bob into the very same pool. Now the pool holds 2,000 and Alice's 1,000 is exactly half of it. 2 honest stakers, each in for 1,000 of their own. Back to the terminal to check the state, I ask the pool for the total staked and it reads 2,000. Alice's 1,000 is exactly half of it, so on chain right now, Alice owns half the pool, just like the diagram. Now, Alice claims, and watch the reward token move. Etherscan shows one transfer inside this transaction. The pool sends Alice 50,000 reward tokens, RWD, half the pot paid to the account that's staked half. Real sellable tokens worth about $50,000. That's honest, the money goes to the person who actually put money in. Now watch someone take almost all of it with none of their own. And the payoff. Went straight off the chain. I asked for Alice's reward token balance, and it's 50,000, half the pot, on a real blockchain, exactly like the test and the diagram. Alice staked half, Alice earned half, about $50,000 of real tokens she can sell. That's what honest looks like. Now watch someone break it. Act 2, the attack on the diagram, and it all happens inside one atomic transaction. The tool is a flash loan. It lends you millions with no collateral, as long as you repay before the transaction ends. Step 1. The attacker borrows 10 million tokens, not 1,000 like Alice, 10 million. Step 2. They stake all of it, becoming about 99.99% of the pool for one instant. Step 3. They claim, and because the pool measures share right now, it hands them almost the entire pot, 99,990. Step 4. They unstake, and Step 5. They repay the loan. They never owned a cent, they were only huge for a single instant, and they keep almost the whole $100,000 pot, which they immediately sell for real money. Alice is left with the crumbs. Let's prove it. Here's the attack test. Alice is staked honestly. With her 1,000, the flash lender holds a big pile to lend, and the attacker contract starts with 0 of its own tokens. It calls attack, which borrows, stakes, claims, unstakes, and repays, all in one transaction. We print its balances before and after. Run it and compare to Alice. The pot is 100,000 honest, Alice has 1,000 stake. The attacker's own capital, 0. Its reward balance, 0. But the flash loan makes 10 million available. One transaction, and look at the scale, 10 million staked against Alice's 1,000, about 99.99%. After the attacker's reward balance is 99,990, its own tokens still 0, loan fully repaid. And the pot left for Alice is 9. Alice earned half by staking half. The attacker took nearly everything by faking a giant stake for one instant. Same pool, same claim, wildly different outcome. Now on-chain. Same story on Sepolia. First, in the terminal, I read the pool before the attack. The pot is 100,000, full, and the attacker's reward balance is 0. Nothing yet. Remember, that pot is worth real money. Now the action, one single public transaction, and this is the important one, so let's follow the money step by step, exactly as Etherscan lists it. Inside this one call there are 5 token transfers. 1. The flash lender hands the attacker 10 million LP tokens, no collateral, on loan just for this transaction. 2. The attacker stakes all 10 million into the pool, so for one instant it owns almost the entire pool. 3. And this is the theft. Watch the reward token. The pool pays the attacker 99,990 RWD, almost the whole pot, about $100,000, because the pool measured share right at that instant. 4. The attacker unstakes, pulling its 10 million back out. 5. It repays the 10 million to the lender, same transaction, follow those arrows, and it's undeniable. 10 million in, 10 million straight back out, and the attacker keeps the entire reward pot, having risked nothing of its own. And back in the terminal, we read the damage of the chain. The pot is down to about 10. The attacker's reward balance is 99,990. From 0 of their own money to nearly the whole $100,000 pot in one transaction, tokens they'll sell for real cash. It matches the test to the token, and you can open that transaction on Etherscan and check it yourself. Act 3. The fix on the diagram, and it doesn't break the honest flow at all. We change one thing, what the pool rewards. Instead of your share right now, we reward your share multiplied by time, how long your stake actually stayed in. This is the standard Synthetix style design. Rewards drip at a steady rate per second, and you earn for every second you're staked, and no more. Now replay the attack. The attacker stakes and claims in the same transaction, so 0 seconds pass, and the reward rate times 0 is 0. The flash whale can still be enormous for an instant, but an instant is worth nothing nothing when the pool only pays for time. And Alice, who really stays, keeps earning her fair share. Let's build it and prove it. Here is the fix in code. Rewards now accrue per second. We keep a running accumulator of reward per token, and every time anyone touches the pool, we advance it by the seconds that passed and bank what each person earned. So claim no longer asks how big are you right now, it asks what did you earn over the seconds you were staked. For the attacker, in and out in one transaction, that time is 0, so the reward is 0. Tie rewards to time, and the flash loan can't fake time. Here's the fix test. Same setup, same flash lender, the exact same attacker running the exact same move. The only thing that changed is the pool underneath, now it's time weighted. We print the attacker's reward before and after. Run it! The pot is 100,000, the attacker's reward starts at 0, it runs the identical flash attack, but now seconds staked 0, rate times 0 times share 0, and the attacker's reward after is exactly 0. The pot is untouched, a full 100,000, still there for the real stakers. Same attacker, same move, and it earns absolutely nothing. Now let's confirm it on chain. On Sepolia, uitunua că se huinat, we deployed the fixed Masako time-weighted pool in the terminal before the attack. The pot reads 100,000 and the attacker's reward reads 0. Same starting point as the broken pool. The only difference is under the hood. Same attack, the very same 5 transfers now on the fixed pool, and let's follow them again. The flash lender sends 10 million LP. The attacker stakes all of it. Then the claim, and here's the whole difference. Look at the amount that moves, 0. The pool pays the attacker 0 reward tokens because it was staked for 0 seconds, and the fixed pool only pays for time. Then the unstake, then the repay. 10 million in, 10 million back out, and this time the attacker walks away with nothing. The pot is untouched. The identical move that stole $100,000 now moves 0 reward tokens on chain, and you can verify it. The fix holds. Back in the terminal, after the attack, the attacker's reward balance is 0 because it was staked for 0 seconds, and the pot is still a full 100,000 completely untouched. The identical attack that stole 99,000 from the broken pool earns exactly nothing here. On a real public chain, you can verify 3 acts 3 ways each: diagram, test, and live on chain. Quick recap, the reward is a real sellable token and the pot is the protocol's budget, real money. Honestly, you earn a share proportional to your stake. Alice put in half and earned half. The bug is that this pool reads your share at the instant you claim, so a flash loan can fake a giant stake for one transaction, scoop almost the whole pot, repay the loan, and sell the tokens, all with 0 real money. The fix is to reward stake multiplied by time, so a stake that lasts 0 seconds earns 0, while honest stakers who really stay keep their fair share. Reward what people actually contributed over time, not who looks biggest for one instant. A quick note, rebuilding DC hacks safely and explaining them line by line takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next breakdown. Thank you. And that's flash loan reward manipulation told in full, what honest staking earns, how a flash loan turns that same pool into a real money theft, and the one change that stops it, each act shown on a diagram, in a test, and live on a public chain. Next episode, another DeFi exploit rebuilt from scratch and then fixed. Subscribe so you don't miss it, tell me in the comments which exploit to break down next, and I'll see you there.